What was that?
Someone turned their car on.
We are studying trig limits.
Oh!
No.
Trig limits.
Please don't.
I'll move you away, so hi.
So there are just a few little formulas that you're going to have to know. And then I'm going to kind of show you this, what's called the Squeeze Theorem. But I'm not going to ask you to formally work those problems. Tyra.
Do they give you formulas? Like on
Yeah.
No, you have to know them all by heart. That's why we do our memory cards. We get nothing. You get nothing. Literally. You get a pencil and your calculator
And God.
half the time.
you get your
You get your brain.
When you get a graphic calculator?
Okay, so let's just kind of talk through, remember what does the graph of sine x look like?
Wavy line.
It's wave line starting at 0. There you go.
Right. What is the period?
1.
Pi over 2. Right?
Keep guessing.
We don't remember.
What happened?
How many radians? This is where you have to be in radians on your calculator. It's
Yeah,
one
it's
revolution.
pi over 2, isn't it?
Nope.
It's pi.
Nope. That's half a revolution.
It's 1. 2
It's-
pi.
Wait, what's a revolution?
You get 2 pies
Ah.
for going around the circle once.
Yay!
This is pi over 2.
Oh, I get it. Cause oh my goodness. If you put them together, it makes 1, 3. Oh, Lordy.
I think we broke
Montaigne just had a revelation.
I just actually understood this now for the first time. Oh, that's that is mind-boggling.
Okay. What's the range?
Let's say 3 pi over 2.
Yeah. What's the range?
1 and negative 1.
1 to negative 1. Right. Okay.
Well, that's... Or, yeah, I guess it does depend on...
And then we can do trig values. I had you write out the unit circle the other day, right?
Yeah.
You have to know the trig values for that by heart. That's why I had you memorize them last
That
year.
thing?
That's why some of you cheated, which was a bad idea.
Who cheated?
I know who it was.
I didn't cheat. I turned
I'm sure it was nobody, but it's somebody did.
What's that?
Tyra.
Okay, so know the values there. So if I ask you, so if you have something like the limit shh, as theta approaches pi of sine x.
Oh, yeah. I missed
Our principles for solving limits still apply here. What's the answer?
Wait, what?
0.
Sine, it's sine at pi, which is 0.
0. Yeah, that's that spot right there. Correct. Okay, so you're still plugging and chugging if you can, right?
Hold up, let me finish writing this down.
You know how much easier last year was doing
Alright.
music, man?
What about y equals cosine x? What does that graph approximately look like?
It starts at pi over.
It starts at
Does that
1.
start
It
negative?
starts at 1.
And goes down to 0.
Looks like this. What's the period?
Pi.
Still 2 pi.
See, it's clicking. I understand.
Now we're getting, our brain cells are getting refreshed.
No, I understand that.
You're refreshed by trigonometry, not by Pepsi. Thank you.
Pepsi dehydrates you.
I know. So does alcohol. But that doesn't stop some of you.
Hey.
What?
Boom, roasted. Hey, I don't drink. I mean,
Yeah, sure.
Do you know what a hangover is, right?
Yeah.
Severe dehydration?
Wait, really?
Yeah.
yeah.
3 pi.
Because alcohol strips your body of its H2O. Yes, ma'am.
Oh, that's why you drink Gatorade after. 3 pi over 2.
Yeah.
That's why. So
It's like
Who gave you that advice?
My dad.
My dad. My dad knows how to drink.
Yeah.
Don't worry, I'm right there with you. And then the range is still the same, right?
Barbie doll.
Okay. Did you ever realize last year that cosine is just,
Yeah.
Oh, whoa, it's just one.
it's shifted sine graph?
Yeah.
Yeah.
Okay. It's shifted pi over 2 units. That's all it is. Just, and then you can also do limits with cosine.
Do you use x or theta?
I used x this time. It doesn't really matter, it's just a variable. We can use English letters or we can use Greek letters.
How
Take
about
your pick.
Negative 1.
Wait, the other one's wrong then, because you did sine x as theta.
Oops. That should be that one. Oh, so what's the answer here then?
Negative 1, right? That's how cosine and sine work.
Yep. Okay, so you got kind of a refreshment on there with trigs, and again, use your limit solutions techniques. Plug and chug is number 1. Okay. Okay, couple special formulas. Can I move on?
I'm confused why it's negative one.
Thank you. How's it negative 1?
Thunder.
That at pi,
Yeah, I get it.
the cosine is
I
negative
got
1.
it now.
I'm sorry. I don't know
Thank
why I
you.
did that.
Thank you very much.
I was trying not to yawn. So you just made an elephant sound instead? What a great
Which is more
compromise.
distracting? Yawning or making elephant sounds in math class?
I'm sorry, you get mad at me when I yawn.
Oh, my dad.
I got mad at you because you yawned for effect.
That's true.
This is on the internet.
Yeah, you
forever.
did that.
Never going to be president.
No.
Definitely never going to be president. They will strip my YouTube channel and call me a racist, homophobic, liar,
Call up your
and a
math
terrible
student.
math teacher. Okay,
Wow.
And
this is one thing that you're going to have to memorize.
Okay.
Okay, we will write a card for it sooner rather than later. That is a fact. Just something you have to have in your Brelin.
Just that right
A
there.
math
Yep.
equation.
At theta equals 0, the limit of that equation.
Limit is theta approaches 0. The sine theta over theta is 1. Okay. What happens if you plug and chug here? You get 0 over 0, right?
Yeah.
Indeterminate form. You don't have any ways to solve this,
Is this
so
trig?
we just give you the answer.
Yay!
But what if we want to prove it?
You can't.
That is right. Like, how
Do you really want to go there?
no.
Yes.
Because we can.
Please do it.
No.
But I'd rather not.
Dang it.
The
I will stab your nipple.
proof,
This.
the proof is in the book.
Okay.
It's in your book if you want to look at it. You have to
We
use
should write
what's
that on
called
our
the
test.
Squeeze Theorem. The graph of that, it's kind of funky. Here's the other one that you have to know.
Is this also just fact?
Yep.
Okay, another fact. Oh, it's going to equal -1.
Well, that's the
Nope.
same thing, isn't it? It's going to equal 1. Oh.
Like I said, we're not going to worry about why.
It just equals
We're
0.
just going to say it's true. Okay? And it's okay sometimes to accept things like that.
Especially
Even though you're taught, like, why? Yeah, sometimes we just accept things because we don't need to worry about it.
What if we like
We do not need to worry about the proof of those. Okay. Kyra, what do you want?
Wait, is it 1 minus cosine? Like one of those identities that we have?
No, that's 1 minus cosine squared. It's equal to sine squared. I had the same problem.
Every time, huh? Okay, next time you have a question, I'm not going to say that.
I didn't where I lost my hand and I sat there.
I hope I remember it tomorrow.
I was like, why?
Okay.
I was like, oh
The-
yeah, I'm not raising my hand.
Okay, just remember those as fact. Here's some of the problems we have where we need to use this. So obviously this is probably not going to be how it's presented. It's going to be some alternate form of it. All right. So you might have something like the limit as h approaches 0 of sine 4h over h.
Oh, this isn't fact?
No, this is a solve. And these are facts. At least as much as we know. Okay, so how would I solve this using this fact? That's the question. Right?
No.
Because this is different. It's 4h, not just h.
But it's
correct?
h times 0 and 0 over 0. It's over 0. So.
But
It's
it's saying
different.
sine of
These are
4
different.
times.
Okay? Right? Just a little bit.
So would it be 4?
A little bit.
Is that one thing? It's still going to equal to 1.
No, because it's sine of 4 times h.
Yeah, so it's still the 0.
Right.
Oh, wait,
Zero.
back up. Isn't this like on the thing at 4? Is that how that is? So it's just translated to the right 4 units?
A lot of pi. 8 pi.
Yeah, you've got a kind of a good idea.
So it would still just be 0 since how the graph works.
Yeah, since it's an even number, it'd just be 0 still.
We have to use substitution here. So I'm going to set 4h equal to theta.
Alright, so it's 4 times 1, so the answer will be 4.
Well, no, 4 is not theta. So.
And now sine of
That's
4
sine of theta
times
over
theta.
So we have now the limit as,
H approaches 0.
no, it's going to be theta now. We've changed it to theta. Sine theta over,
H.
No, theta.
It'd still be H though, because 4H is theta.
so what is h equal then?
0. Or 1
1.
over 4
1/4, right? Okay, do we still have a small problem?
Yeah.
It's a small problem. Now it's just a numeric problem. This is equivalent to
Okay, I get it.
4 times sine theta over theta. Right, because 1/4 you can flip it and multiply, right? It's fraction division.
So the answer would be 4.
So this here is 1, right? And the answer is 4.
I knew it. So in the original one, why can't you just take out the 4 at the top? So it'd be 4 parentheses sine H.
Well,
You just can't take it
it's
out.
not proper mathematical form.
Oh, okay. But like you could just kind of see it.
On these ones, it would probably work just about every time,
Okay.
but it's just not. But the problem comes, what if you have something down here like 2h?
Well, then you don't do that.
So you got to kind of work those. Okay. All right, so that's one way you can use those.
There's a no H.
Let me see if there are any. You're going to have to use your trig identities here too. Okay, so let me just see if I can pull one out of the hat here.
What's in a half?
You're going to use your identities in your algebra. Let's try the limit as t approaches 0, cosine t minus cosine squared t over t.
Cosine t.
Cost. What is the cost of this?
Curve it.
Does that say 0 or S?
You must give up your life in order to do calculus.
I give up.
Take me to church.
Okay.
Shut.
Okay, does this look exactly like one of the facts that we have?
Yes, sort of, no.
Kind of, right? It's got a minus on top and a cosine and then it's over t, right? So can we make it that form?
Yes. Because the
So
cosine-
plug and chug, you're gonna get this, right? We check it every time. What do I need to do to the top?
Cosine squared is equal to 1 minus sine squared.
Somebody said factor. I'm gonna go with that.
Ouch.
Pretty sure 100 was great.
The one minus.
Right? Now does that look a little more
Oh,
Yeah.
okay.
familiar?
Yeah.
I was wrong.
Like
Oh,
just
you failed me.
cosine t multiplied by sine t, right?
What's the cosine?
Evelyn.
So basically, are you trying to make it as close as possible to this, or like when it comes
You need to
out?
make it exactly that with a little bit of trash on the front end.
And then the trash is the answer.
Yeah, so this is exactly what we just, the fact, right? What's the answer to that?
Over t.
Or it was 0. So the entire thing is just 0.
Yes.
0, right? Fact. 0, does it matter what that is?
No.
No, it
Absolutely
doesn't.
not.
But it is also, it's 1, right? So our limit is 0. Now, let me do this the way I teach you to do it. Have good for myself. Equals 0.
I have a question though. So if you just, so instead of making it below it, you just did that original one equals cosine t, like you just show your steps, do you have to rewrite the limit every time?
Yes.
Even in that case?
If
Even
you
if
don't
it's
write the
connected
limit,
like
you
the
have
chain,
written
you
2
can-
equivalent heading, 2 statements that are not equivalent, you've written them equivalent. It's like saying 1 equals 0.
Well, I've been doing these wrong this entire time now.
So if you, yeah, if you write that these are equal, you have to carry the limit with it, right? Because it is different.
It's 6 statements.
That's what, write the limit every single time, because it will pay dividends. You probably won't get busted on it for points, but they might just go there. You never know what the graders are gonna do, or what your teacher's gonna do, if you have bad forms.
Wait, but, so this right here is wrong? So I did limit theta is first, and then I showed that.
Yeah, that's, you need to write limit here.
Oh my lordy.
Yeah, tell me about it. What about this?
Wrong.
One more.
The answer's God.
And the hush.
Stop using T's.
Stop.
Why?
Yeah,
Because they're obnoxious. and pain
T's
their
are not
people.
obnoxious.
They very much are. Switch it.
No, you need to get used to using T's because we're going to use them a lot this year.
Why? It's just
Why?
a variable.
Because
It can
T
be
is a
simply-
great variable example for time.
Okay.
Oh, yeah, I that's
You
the
just need to get used to using any old variable. It doesn't matter.
You can use Z or X or W.
Yeah, you could. Yeah.
Could you choose 25?
Any ideas on how to start this?
So you just divide.
Wait, yeah, could you just
Factor, or not factor,
Stop. How do we start a limit problem?
I'll plug it in.
Thank you. What do we get?
Zero.
I think.
Probably.
Anyways, okay, now what do you think?
You just
Okay, yeah, use your
Wait,
identities.
Isn't that improper form? Because you're supposed to limit T to approach to 0 before
No.
you did the 0, 0.
This is true.
because he's saying as that equation stands, if you plug it in, it's equal to 0 over 0.
Cosecant is 1 over sine, right?
Yeah. Yes. Yes.
So 1 over sine 8t?
Now we can fraction division, right?
Yeah, so you get sine over sine.
Now this is where we write the limit again to make these
Okay.
equivalent statements, okay? So sine 4t,
Over sine 4t.
sine 8t.
Yeah, that's a guarantee.
Okay, now I'm gonna think.
So cosine here is sine over cosine, which is one side, 1 over sine. That's what that means?
Yep.
Okay.
Wait, I have a question.
Yeah.
How did you get rid of the one over?
Oh, fraction division, copied off the.
It's a fraction divided by a fraction is a real number.
Yeah, at this point in basic math, looks really.
1 over sine. Okay, that's the top. Copy, dot, and then flip the bottom. Over fraction division. So that's what you get here.
Did you overtake it?
We're in. This is 2.6. I'm gonna cheat.
Yeah.
Yeah, you get this dodo dying.
What?
This Doyle started crying. She was laughing so hard in our chemistry class.
No way.
What'd you do?
She's got this piece of fur. and
Oh
she
my
got
gosh.
it.
Oh,
Everyone in
God.
class had a giant argument about it, and everyone's like, "Oh, it's a squirrel." And I'm like, "That's not a squirrel. Squirrels don't look like that. That is a cat.
All right.
Not even like a
And
ball
they went
cat,
to
like
Whitley.
a house cat."
I said
Oh
that
my god,
too.
he said that!
I said that.
So
Okay.
Obed and some people went to Mr. Whitley and asked him, and came back like, "Totally a house cat."
She said it died in that
He just sat there because Kellen's like,
I knew it. Screw up.
Yeah, just called it.
dead head on a balloon for science.
That's
Okay, Hunter, I'm pretty sure that part of that conversation came up because Chapman and Chance started playing with that stupid coat in the class.
And they're like, it's a bunny. I'm like, no, it's a cat. Well, did
No,
we
I
use
called
Okay.
it fun.
That's awesome.
Does this look like what we have already?
Oh god, we just told her Doyle story on the internet.
not exist?
Hi guys. Love you all. Can you just strip out the 4 and the 8?
Okay.
Oh god.
Whoa, where did that come from?
Well, I'm splitting it up because we want to make it look like sine over something, and right.
Well, it's just over one.
So
But then,
it is right now. Okay, but is there something we could do to these to make them look more like the facts that we know?
Take 4 out of both
Okay.
of them.
What if I did this?
over 40.
Does that look
Yes.
okay? But this one would have to be 8t, right?
Yeah.
I've made this imbalanced now, correct?
Yeah.
So I have to actually multiply by half here to make it 8t and 8t, right?
Ah.
So all I've done is 8t on the bottom, 8t on the top.
Right.
No,
Okay.
I'm lost.
Then you should just have to turn the one on the other side.
Yeah, sine 2t.
Now where you go?
Okay, well this,
Sine
we have 1/2, right?
32t.
Then you get 16t over 16t.
This is 1, because we could substitute with theta, right? Theta over theta, so this is going to be 1. Any ideas?
1.
Why?
You substitute with beta.
So the number
No,
is
it's
nine.
2.
Jeff, what's the reciprocal of this?
I don't even know.
What's the reciprocal of 1?
Two.
There you go. So your answer is 1/2.
Did you change colors?
Yeah.
Yeah.
Okay. Thought I was going to like Hunter.
That's actually honestly harder than I'm going to actually do on a test or anything, but you kind of see you're always noticing our form kind of looks like our fact, and we're trying to manipulate it in some such way to make it look that, okay?
Bless you.
We're going to have to clean that up. You're going to have to clean that up.
So the 1/2 simply multiplied the
Yes.
bottom by 2.
8t,
Okay.
8t, still the same problem, right?
Yes.
Okay.
That, when you multiply it by half, it's just like finding the greatest common factor, right? Or trying to.
Well, if you put an 8t up here, it has to be 8 on the bottom. So 2 times 4, 8, right? Okay, here you go. I did not show you the squeeze theorem,
Wait, where does one have?
Is that 2.6 or 2 comma 6?
What section are we in?
Well, I don't know. I figured we know what section we were in, so I just wanted to give it.
We're in section 2,6 because that's what they do in Europe.
Action? Yeah.
Europe is a weird place.
They think we're a weird place.
Yeah, this is true.
We are a weird place.
Yeah,
We
we're
are about
heated over there.
No, we're just different.
No, we are heated.
Everywhere in the world is a weird place because.
Okay, so you got your problems, all odds. So you're checking your answers, right?
Right.
Yeah.
Plus some spiraling.
Okay, huh?
Is this due tomorrow?
What do you have
3 contents.
going on this week, like tonight? I can move things around a little bit.
I have no life.
Like if you have time
got it.
tonight
Just make sure you don't give us homework.
versus tomorrow night. Next week is your first test.
Yeah,
We've
we've
got
got
FRQ.
They're like, oh, we don't want to give homework.
We've got FRQs to go.
So would you rather have 2 days tonight? Or would you rather have 2 days? Like tomorrow we can do an activity that will give you 2 days here. Or I can teach you a lesson tomorrow and give you 2 days on that assignment.
Well, what's
This one's probably shorter,
Let's do the latter on the longer one.
so.
Yeah.
Work on the ladder.
Yeah, definitely, let's do tomorrow. That'd be better.
Okay.
Limits at infinity or. Okay,
So,
well, that doesn't help.
69 cents.
Nice.
Here's my 10 cents. That's yours.